So yesterday we started with cloud computing. So we will talk about how the global infrastructure of AWS look like. I told you what AWS has is a number of data centers throughout different locations. They have data centers in Mumbai, they have in San Francisco, California, right? Ireland. In different parts of the world, they have sets of data centers. And inside these data centers, they would have procured a lot of machines, right? They would have purchased a lot of Linux machines or Windows machine, and they would have installed the necessary software in it, and they all are attached to some network. They also have a lot of network devices which get traffic from internet, right? And all these data centers work together to give you a virtualized environment which you get as a service. So when I click on creating a new machine, I click on launch instance button. I select Ubuntu as the operating system. Then I launch the machine. Then automatically this machine is created in some data center based on what location I have chosen. Let's say if I choose Mumbai as my region, then my machine is going to be created in one of the data center in Mumbai. And also the machine which is getting created is not a actual machine, it is a virtual machine inside the data center of AWS that is in Mumbai. They will have an actual physical machine. Inside this physical machine, they would have some virtualization software running. This software would virtualize the complete machine and give me a part of the machine. For example, that is a 100 GB RAM, and the machine that is there in the AWS data center, it may have 100 GB RAM and 100 core CPU. And the virtual machine that you are creating inside this big machine, that machine would get shared space. Maybe it would get some 10 GB of RAM and some 5 core CPU based on what type of machine I have chosen. So this is actually what happening. But right, I mean, I don't really need to bother about what AWS does in the backend. Okay. Okay, great. So a region of AWS is nothing but the places where AWS is providing these services. Regions are the geographical location in the world. For example, Mumbai, San Francisco, Ireland, like that. There are number of places in the world where AWS is providing these services. If you create a EC2 machine, or you create a network, or you create a database, you have option to create all these things, and you can create these services in one of the places which AWS offer as regions. And you can see the list of regions. Actually, what you see in the PPT is a outdated list. Sorry about that. If you're going to log into AWS, aws.amazon.com, click on sign into the console. Log in with your mail ID and password. On the right side top, you can see a place name. If you click on it, you have the option to choose whichever place that you want to create your services in. For example, I want to create a EC2 machine. I want the EC2 machine to be created in Ireland instead of Mumbai. Then first I can change my region to Ireland. So click on Ireland. I am changing my region. Now if I try to create a new EC2 machine, if I go to the EC2 page, now I try to create a new EC2 machine, then the EC2 machine that I am going to create would be created in one of the data center in Ireland. right? It's not just EC2 machine I can create. I already told you there are many things. You can create network, you can create storage devices, you can create database devices, you can create different gateways, many things you can create. Whatever thing that you want to create, they are physically located in one of these places which you can choose. It's up to you to decide which place you want to create these AWS resources. That's what a region is. Okay, so within each region, that means in Mumbai, in Oregon, in California, in Singapore, Sydney, in all these region, what AWS has is a lot of physical buildings that they are called data centers, where they are keeping their hardware resources. And like I said, they are virtualizing their complete data center to provide you all these things as a service. Okay, fine, great. So the availability zone is within a region, they had classified the data centers, put them into different availability zones. Let's say there are many data centers. You group a number of data centers in Mumbai, you call it one availability zone, and then you group another set of buildings and data centers in Mumbai, you call it second availability zone. So like that, within a region there can be two or more availability zones for every AWS region. So why availability zones? Actually, AWS, what they guarantee you is, let's say inside this data center you are creating one EC2 machine, and inside this data center also you are creating an EC2 machine. Here you are creating one EC2 machine inside this data center. So your EC2 machine that you are creating is spread across multiple availability zones. What AWS guarantees you is that even if one entire availability zone become unavailable, the chances are very less that that is going to affect the machine on the other availability zone. You got it? So basically, I don't know what they had done, or I don't know how they make it possible. Maybe they are using internet connection from a number of providers, and those connections are shared only across these data centers. And these data centers would actually get internet connection from different providers. What it means is probably the chances are very less that both the internet connection will go down on both availability zone at the same time. Let's say all these providers become down, unavailable, then it can affect all data centers in this availability zone, but probably this availability zone is still going to work, right? I mean, basically, through some physical ways and through some through some functional ways, AWS does a lot of work to make sure that there is a problem happening in one of these data centers in this availability zone. The chances are very less that it is affecting the other availability zone. So in a other way, what you can say is, if you have two machines, one machine in one availability zone, second machine in second availability zone, chances are very less that both machine can go down at the same time because AWS has a problem, right? Any problem can happen in a data center, right? I mean, it's completely unpredictable. Maybe there can be a fire in the data center, right? And there are too many computers sitting down there. There's a problem with the AC, or there's a problem with power, right? There's a problem with heating up the data center, or maybe in fire. There are many chances. There can be a crash here, or the internet connection is completely down. Anything can happen in any of these data center, but AWS can configure their data center in such a way that they are spread across different availability zone. And what AWS guarantees you is that even if one availability zone is down, the other availability zone will be up. So if you have a EC2 machine, two EC2 machine, one in one availability zone and other in other availability zone, the chances are very, very less that both are going down at the same time, which is actually very much practical. Okay. Jay says he's not able to hear me. Is it same for everyone? Do you find any problem with my voice or anything? Okay, it's fine now. Okay. Okay. So that is what an availability zone is, and there can be two or more availability zone in each region. Minimum is two, maximum is I think five or even six, maybe more. Right? Okay, fine. And it's up to you. You can choose when you want to create a new machine. You can choose which availability zone the machine will be created. That is something you can choose. Fine. Okay, so the next thing is edge location. Edge locations are nothing actually, it's a different service altogether which AWS provides. AWS has machines all over the world, not only in the regions. Regions are only 15 or 16. Only these many places are the region. Apart from the region, AWS has machines all over the place in the internet. Their responsibility of this machine is that the machine does a lot of caching. People from internet, they want to browse for different websites, right? AWS would serve them with from their nearby locations, right? Let's say I am accessing a website from Bangalore. I will get the content of the website from Bangalore itself. Or somebody from Delhi want to browse for a website, they will get the website content from Delhi itself. There are machines all over the world which are owned by AWS, but these machines are for some special purpose, caching the internet data and serving it to the people who are nearby to them. So those kind of places where AWS has the machines in, they are called edge locations. It's actually absolutely all the countries and all the states. Okay, so that's it, and we will start with EC2 today. Just take a short break of 5 minutes. I need 5 minutes. We will continue in 5 minutes, and we will start with EC2.
Mr. Basil.
Yeah, actually, can I come back?
Okay. I just log in. What was the review? I just log in right now. What was the review? What you were talking about?
We were discussing AWS. These are the services that we are going to learn in AWS. We are going to learn VPC. VPC is the service where you are going to create the network. I told you you can create virtualized network in AWS. It will look like a real-time network, even though it is not. It will actually look like a traditional network that you create in your office. So we will set up such kind of network inside AWS when we learn VPC. And EC2 is the place where you can create the machines, right? You already created a Ubuntu server 16.4, right, for your lab, and you did that from this particular service of AWS, the EC2 service. So we will learn about this EC2, and then IAM is a service. Basically, within AWS you can create different resources. You can create network, you can create machines, EC2 machines. You can create storage devices. You can create databases. Who will have access to those resources is something that you can decide. Actually, AWS provides one service. It's called IAM. It's a service that AWS provides through which you can actually decide who will have access to these resources. Maybe in your company there are multiple people, there are developers, there are DevOps engineers, there are some other monitoring team, there are different team. All this team would need some different kind of access into the AWS resources. So who will get access, what kind of access they will get on those resources, all these things you can decide. And there's a service which in AWS that helps you do that. It's IAM, identity and access management. It's more like Active Directory, or I don't know whether you heard about Active Directory or LDAP. It's more like a identity and access management system that AWS provides that let you determine who will have access to the AWS resources. Then S3 is a storage service, actually a storage place inside AWS where you can keep your files, right? If you have lots of images or lots of HTML static files, you can actually place all those files inside the S3 storage and you can use them whenever you want it, right? It's just a storage place where you can save large files or small to large files. You can save files which has size in terabytes. That much huge files you can save inside S3. Route 53 is the DNS service. I mean, it's not generic. I mean, it's a generic server. I mean, you can make Route 53 as your authority name server, as I had shown you how to do that. So we will learn about Route 53 in detail, how you can add a hosted zone into Route 53 and how you can configure different DNS records. So you don't need to set up your own resolver name server, or you don't need to set up your own authoritative name server. Instead, you can get them all from Route 53. SCS is a service in AWS that provides you SMTP as a service. If you want to send out an email, you need SMTP. One SMTP server you need. So AWS provides you the SMTP server as a service. Basically, you get the SMTP server credentials using which you can send out email. That's what SCS is. RDS is a database service. You can create a database and AWS would give you access to the database that you have created. CloudFront is a CDN service that I talked about. If you want your website to be cached all over the world, let's say you have a website basil.com and you want basil.com to be cached all over the world in the edge machines of AWS, and you want people browsing from different part of the world being served by from their nearest location. Let's say somebody browse for basil.com from New York, they get basil.com from a machine which is in New York. If I browse for basil.com from Bangalore, I would get basil.com webpage from a machine which is located in Bangalore itself. So basically, it would avoid the network latency and it would avoid the internet traffic bandwidth. It would, it would save a lot of internet bandwidth and it would save a lot of money of you. CloudWatch is a monitoring service. If you want to monitor any other AWS resource, for example, you want to monitor your EC2 machine. If the EC2 machine is going down, you want to get notification. Or if Apache running inside your EC2 machine is going down, you want to get notification. So CloudWatch is a service which is used for monitoring other AWS resources. Then we have EC2 command line tools. It's nothing but actually we are going to talk about both EC2 command line tool and Boto module. Basically, how you can work with AWS. one way how you can work with AWS. You can go to your browser, log into the AWS console. Then if you want to create a machine, you can click on launch instance to create a machine. Apart from doing this manually from your browser, you can actually run some script on a remote machine, maybe on your laptop. The script will actually create a machine inside your AWS account. That is also possible. You can work on AWS using some script. So in this session, when we are learning this, we will talk about why you want to work with a script and what are the advantages, and we will see how you can actually work with AWS resources using some custom script. So these are the different services that we are going to learn in this training. And I am expecting 2 weeks for cloud computing training. We will probably finish, most probably we are going to finish all AWS classes by 12th of Jan, and then we will start with, I think, 11th of Jan, and then we will start with the DevOps tools training on the same day. That is the plan. So yeah, let us start with EC2 or the virtual machine management. So go to the AWS page. Over here you can see you are inside the EC2 page. Click on services, then click on EC2. You would be taken to the EC2 page. And you might already know, how to create a new machine. But maybe some concept you did not got it right. Or I just did not explain that to you. So we will just take a look. What are the different options you would get when you try to create a new machine inside AWS? Very important. So click on launch instance. I want to create a new machine. Click on launch instance. The first page that you see is nothing but a list of operating systems, right? Amazon Linux, Amazon Linux 2, LTS, right? Long time support version. Red Hat, Ubuntu Server, SUSE, right? Like that, there are different operating systems which you would see in the first page. Windows 2012, Windows 2016. You can see different operating systems. Actually, even though the description says the name of the operating system, these are not actually operating systems that are being listed down here. They are actually the Amazon Machine Images or AMIs. On the left side, you can see different options. There is one option called My AMI. These are the AMIs that AWS provides you, which you can use. Or you can click on Community AMIs. You will get a list of AMIs which you can choose from. You would see Ubuntu 16.4, Ubuntu 14.4, Ubuntu 12.4, Red Hat, SUSE, or Mint OS. Whatever operating system you want, you can search in the community AMI. There is a wide variety of lots of operating systems available here. And there is a place, something called AWS Marketplace also. There also you would see a lot of AMIs that you can choose from. So we will come to that. So first take a look, what is an AMI? It's not just an operating system. It is the complete image of a machine. Let's say you have a machine and assume this machine is running some operating system, let's say Windows. And inside this Windows machine, you installed Google Chrome, you install Firefox, then you install some other software, let's say Apache. Then like that, you installed a number of software in this machine. And you already saved a lot of data. You downloaded some movies in this machine. You saved some files inside this machine. You have a lot of data also saved inside the machine. So there are softwares, there are files, there is a operating system that the machine is running. So there are many things inside this machine. If you take an image of this machine, the image will contain everything. It's more like a full backup of the machine that you can use later to create a new machine. Think about that. It's something. Image is nothing but a full backup of the machine that would include whatever the machine contains. It contains the operating system, the software that you have already installed in the machine, the files which are already present in the machine, combining everything. it's a complete system backup is what you call an image is. So in AWS, they call it AMI. It's a way of taking the images of a complete system. Or if you have a EC2 machine, you already created a EC2 machine, your Ubuntu server you created. Inside Ubuntu server, you installed Apache. Then you added your website into it, right? Then what you can do is you can take an image of this machine or AMI of this machine. And from this AMI, you can launch new machines. You can launch multiple new machine. All this new machine will contain, it will look exactly like the original machine from where the AMI was created. So if I install Apache and set up a website, then any machine which I create from the same AMI will also have Apache installed, and they are all configured with the same website in it. That is what an AMI is. It would contain everything a machine would contain. That is what an AMI is. So in this page, you are actually choosing the AMI. Even though the description reads and it does look like a operating system, it does not. It is not just an operating system you are actually choosing. So creation of the machine from this AMI on the AWS part, what they do is they will just take this image, copy this image into a VM. That's all they do. It's not, there is no need of installing the machine and setting up everything. Remember, if you had your laptop and how you installed the operating system in your laptop, first you had the ISO CD, right? You burned the ISO file into a CD drive. Then you booted your computer, your laptop from the CD drive. Then you installed the operating system. It downloaded some updates. It did some lot of changes in your laptop. May copied a lot of files, and finally, the operating system got installed in your laptop. But in this case, creating a machine from the image is more like simply copying the complete image inside this machine, and the machine is ready. Basically, that is what AWS do when you create a new machine. That is the reason it is so fast. Whenever you create a new machine, all it takes is couple of seconds to create a new machine, right? The reason is nothing but this. It's all about what AWS does is they will just copy this image into a machine. That's all they do. That is the reason your EC2 machines are getting created in. You may have figured it by now. I mean, not in the world you cannot install any operating system in a machine within 2 seconds. This is the reason. Actually, it is not a OS installation that happens when you create a Ubuntu server. It's actually a image restore. So all time it takes is to copy the file, copy the image into the right container. So yeah, I'm choosing my AMI. I want Ubuntu Server 16.4 to be my AMI. Click on the select button. Debabrat, yes. The answer is yes. So I am selecting Ubuntu Server 16.4 as the AMI. Then I would be taken to the next page where it will ask me to choose the instance type. You already know what it is, right? There are different types of EC2 instances: T2 Nano, T2 Micro, T2 Small, T2 Medium. So based on what type you are choosing, on the right side you can see how much CPU you are going to get and how much memory you are going to get. If you choose T2 Nano, it's going to be one CPU and 500 MB RAM. This is one CPU and 1 GB RAM. So T2 Small is like this. So you can have create machines that has up to 732 GB of RAM and 64 even more. I think even more you can create 1952 this much GB of RAM and 128 CPU. This much size machine you can create. So you can actually create very large machines by choosing the respective instance types. And within the instance type, you would actually see there are some classifications here. There are these machines, the machine starting from here till here, right? Till here, they fall under this category, general purpose. There's a family called general purpose, and a number of EC2 instant types fall under general purpose category. So the general purpose instance is nothing but they can be used for whatever purpose that you want to, and they are not any optimized machines that will do a certain job, which I will come into. If you come down, you would see different family called compute optimized, and C for large, C for X large, C for 2X large. There are few different types of instances that fall under the family compute optimized. What it means is you can choose one of these machines if you are running some software inside this machine which need a lot of CPU. Basically, your intention is you want to run some software in this machine, but you are expecting this software is going to use a lot of CPU. It is a CPU bound software, which means I need a lot of CPU if I want to run this software. So such software, your plan is to deploy such software into these machines. You could rather go with one of these instance type, compute optimized instance type. They will have good amount of CPU power. Also, the machine itself, they are optimized to get good CPU power. Maybe they are using good hardwares for CPU. I don't know, right? Basically, they are compute optimized machines. And if you come down further, you would actually see GPU compute. Basically, if you want very powerful compute optimized machines, if you want the CPU to be very powerful and the application is using CPU very huge, in such case you can go with even further GPU compute instances that provides a good high performance CPU. These machines can serve you. And come down even further, you can see memory optimized instances are for large, right? Are for X large. Like that, you can have a number of machines which are memory optimized. What it means is the that machine, if you have any application that need lot of memory, for example the database, you want to run some MySQL database that you are expecting a lot of data you want to save in the memory, in the RAM. In such situations, you want a memory optimized instance. You can choose from one of them. So based on what you need, you can choose the respective family. Sometimes you want your database to be expecting a lot of read and write from the hard disk. You can go with a storage optimized instance. The hard disk of such machines would be very fast and powerful. Okay, so these are the different type you can choose from, but in your case always go with T2 micro, and you know the reason. Only T2 micro is free. So select the option T2 micro and then click next again. You would be taken to a page where it would ask you how many machine you want to create. Is my voice breaking? Do you find my voice is breaking?
No.
Okay, okay. Let me know if it is, if you find any problem with my voice. Okay, here you can mention how many machine you want to create. You want to create only one machine, or you want to create two machine or three machine. How many machine you want to create? Request spot instance. I will come to it. Right, I'll come to that. There are different type of machine that you can create in AWS, right? So by default, it's called on-demand machine, which I am creating. We will come to the different type of machines. Then here I can choose to which network I want to add my machine into. I told you I can create network in AWS, right? The virtual network. I can click on some different buttons in AWS to create network. Then whichever EC2 machine that I am creating, I can launch the machine in this network. I can attach the machine to this network. I have the option for that. So this is where I can choose that to which network I want to place my machines in. And within a network, you can have multiple subnets, and this is where you can choose which subnet in a network you want to add your machine into. We will come to these topics later on, right? We will come back to this topic. How to create network, how to create subnets, all these things we will discuss. This is the place you would choose to which network you are adding the machine into. Auto assign public IP. Basically, I told you this. Of course, the network that you create inside AWS, what kind of network it is going to be. Is it a local network or is it a public network? The network which you create inside AWS, that has to be a private IP, private network, not a public network. So that's what you create through the VPC options which AWS provides. You create a network. Apart from that, you want a public IP for your machine. If you want to connect from your putty, you are at your home, you open putty and you want to connect to this machine remotely. In that case, this machine need a public IP. So I can request for a public IP to AWS by selecting this option as enable. Use subnet settings. By default, it is enabled. So basically, if I choose enable option, I will get a public IP on the machine which I am creating. So if I have a public IP on the EC2 machine that I am creating, what it means is from outside world, I can connect to the EC2 machine using this public IP because it is a routable IP on the internet. If I choose the option no, I have also an option. I can choose from the drop down. I can choose the option disable. If I choose disable, what will happen? Then I cannot connect to the machine. The machine is not shown to the internet. This would become a machine which is not shown to the internet because there is no public IP. People from internet cannot connect to this machine if this machine does not get a public IP. Okay, so I want public IP on my machine. So I want to request a public IP from AWS for that because public IP is not something which I have control over. It's only the network that I create in AWS, the VPC. I get control, but I don't get control over the public network of AWS. I need to request AWS that please give me a public IP on my EC2 machine. I am rule a role. We will come into that. All right, we'll come to it. Shutdown behavior. Basically, maybe you may have done that already. Once you created an EC2 machine, you can right click on the EC2 machine, stop the machine, or terminate the machine. Right? You have the option. You can do that from AWS console. Okay. So what if you shut down the machine from the machine? Let's say you logged into the EC2 machine using your putty. Then you can run a command shutdown. Shutdown is a command that you can execute in Linux, which will shut down the machine. Or if it is a Windows EC2 machine that you created, a EC2 machine run with Windows operating system, you logged into the Windows from remote place, then you go to the start button, you click on shutdown, the machine got shut down. So what you are actually doing, you are trying to shut down a virtual machine from the operating system. Is it possible to shut down a virtual machine and start the virtual machine when you want it? You cannot. There is no such option like keep it shut down, then boot up the machine when you want it. This is not a physical machine, this is a virtual machine. So if somebody shut down the machine from the operating system, what actual action should happen, whether the machine should be stopped or whether the machine should be terminated. I can choose what will happen if somebody tries to execute the shutdown from the operating system. So by default, if somebody tries to shut down the machine will go into a stopped state. Or if somebody tried to shut down the machine, I want the machine to be terminated, I can choose the second option, terminate. I would rather choose the first option, stop. And enable termination protection. Basically, maybe you may have noticed, if you right click on the machine, then select the terminate option, the machine will instantly get terminated. So it is possible that you can accidentally terminate a machine by mistake. So if you check this box, basically it would avoid such kind of accidental termination. Now if you check this box and if you are trying to terminate a machine, it will give you a warning saying that you have enabled termination protection, so termination is not allowed. First you need to change that settings, then you come here and terminate. It would give a message to the user. If you want some monitoring enabled for your EC2 machine, by default AWS will monitor the EC2 machine. Once you created it would monitor whether the machine is up or down. All these things is AWS will monitor. If you want any additional monitoring to be performed by AWS on your EC2 machine, you can check this box and that would include some additional charges. Over here I can choose, should it be a dedicated machine or should it be a dedicated host? I think I need to drop today's class now. Actually my baby is making some nuisance and his mom is not here. Yeah. Any questions?
No, Basil.
Anyone? Any questions?
No, Basil.
Okay. Cool then. So
No, sir, you get, yeah, Basil.
yeah, go ahead.
Yeah, it's Harsha. The list which you have showed in the PPT, is it all the services provided by the AWS, or
No, there are lots
the
of
one which we use usually?
the one which we are going to learn and the one which every company uses very commonly. Are the very popular services which are essential part of the
Okay.
infrastructures.
Okay. These services we will use basically, right? All the services we will be using.
Yeah, in our project we would be using all these services. We have a project to do in AWS and where we will be covering all these things.
Okay, okay, okay. Thank you.
Cool.
Okay, Basil, take care.
Yeah. Thank you, and have a happy weekend. Right. See you all
Happy New Year.
Monday.
Yeah, Basil. Tomorrow is the class is there.
Tomorrow we don't have class. Tomorrow we
Oh,
don't
Saturday, Sunday, Sunday, no class, right?
have classes. Yeah, no classes on Saturday and Sunday.
Okay.
Next
Happy New
class.
Year, Basil.
Yeah. Happy New Year. Happy New Year all.
yeah. So we will meet on Monday. Basil.
Yeah, Monday is the next class. Monday, same time is the next class.
Okay.
Okay.
Yeah.
Happy New Year, Basil.
Yeah. Happy New Year. Thank you.
Happy New Year, Basil. Yeah. Take care.
Yeah. Bye bye.
Bye bye.